Here is question number 16. A semicircular metallic disc of radius capital R has two small cavities of radius R1 and R2 shown in the figure. On heating the disc, you are having four options and you have to pick the correct one. R increase, R1, R2 decrease. Option number 2, R, R1 and R2 all decreases. Option number 3, R and R1 increase and R2 decreases. Option number 4, R, R1 and R2 all increases. Now we know that due to thermal expansion on heating, intermolecular distances increases, and hence we can say that all radii will increase. So, due to thermal expansion phenomena on heating, intermolecular distances increases. Therefore, all radii increase or increases. So that's why we will go with option number 4, which is absolutely correct. Now let us proceed to the next question, that is question number 17. Three rods P, Q and R having same area of cross sections and length are connected with each other as shown in figure. The rod through which no heat will flow will be what, given that the thermal conductivities of rod P, Q and R are 2K, 4K and 2K respectively. Now suppose, let us consider the temperature of this junction is T. Now after calculating this temperature, we will be able to find out on which rod the heat will flow or not. See, suppose the rate of flow of heat is H1 here. In second rod or rod R, the rate of flow of heat is H2. In third rod, that is rod Q, the rate of flow of heat is H3. So H1 flow will be combinedly equal to H2 and H3. So we can write, according to law of heat transfer, we have heat of flow in rod H1 is H1, which will be equal to H2 plus H3. The rate of flow of heat can be written as dQ1 by dt in rod P will be equal to sum of dQ2 by dt plus dQ3 by dt. dQ1 by dt can be written as 2K area length L temperature difference 100 minus T will be equal to 2K for rod R, area same, length same, temperature difference T minus 20, that is T plus 20, plus for third rod, that is Q, 4K area A, length same L, temperature difference T minus of 40, Ka upon L, Ka upon L, Ka upon L will be cancelled out, and ultimately we will get 200 minus 2T equals 2T plus 40 plus 40 minus 160, and after solving we will get the temperature of the junction T as 40 degrees centigrade. Now if you see rod number Q, there will be no difference in temperature, 40 and 40, and since there is no difference in temperature, that's why no heat will flow in rod Q. So after looking at the option, we can say that option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question, that is question number 18. So here is the question number 18. An ideal monoatomic gas follows a thermodynamic process as shown in figure. Pressure volume PV plot is given. the work done by the gas in process AB will be what? So here we can say that PV graph is a straight line, and its equation we can simply write P will be equal to slope of this graph multiplied by V, where M is the slope. We can easily calculate the slope. Slope is what? Perpendicular divided by base, that is P naught upon V naught multiplied by V. Now we know that the work done by gas will be given as P dV. From limit, the gas is expanding from V naught to V1. Putting the value of expression for P, we will get P naught V naught V dV from V naught to V1. Let's solve the integration. Work done will be P naught constant, V naught constant, comes out of the integration. Integration of V will be V square by 2 from the limit V naught V1. Take 2 outside, P naught upon 2V naught will be, putting the limits, V1 square minus V naught square. So this is the final work done by the gas. And after looking at the options, we can say that option number 1 is absolutely correct. So we will go with option number 1. Now let us proceed to the next question, that is question number 19. Here is question number 19. Mean free path of a gas molecule is. So there are some quantities given like diameter, temperature, number of molecule and pressure. First of all, we know very well the mean free path of a gas molecule is given by the expression 1 by under root 2 times n pi d square, where n is concentration of molecule, that is number of molecules per unit volume. D is the diameter of molecule. So from here it is very much clear that lambda is inversely proportional to n, lambda is inversely proportional to d square. Now let us try to find the correct option. Directly proportional to the diameter of molecule, which is incorrect. Inversely proportional to the temperature, there is not any term temperature mentioned, so again incorrect. Inversely proportional to the number of molecules per unit volume, yes, it is true. So option number 3 is absolutely correct. Let us check option number 4 as well. Directly proportional to the pressure of gas. No, it is also wrong. So that's why we can say that option number 3 is absolutely correct. So we will go with option number 3. Now let us proceed to the next question, that is question number 20. Here is question number 20. The total energy of particle of fixed mass performing simple harmonic motion depends on time period, amplitude, time period and displacement, amplitude and time period. We know that the total energy of a particle executing SHM is given by the expression half of m omega square amplitude square. So after looking at the expression, we can say that this energy is depending upon omega, that is angular frequency, and amplitude. So we can say that it is depending upon time period as well as amplitude. So we will go with option number 4, which is absolutely correct. Now let us proceed to the next question.